Hello, this is the second exercise from exercise 6B.2. The first one we just introduced the idea that we've kind of seen before at GCSE, but many of you won't have seen this formula here. This formula here is widely used in A-level maths, so we've got to get our head around it. So it might as well be now. But we will use it in a lot of different places, so make sure you understand this by the end of this. Little starter first of all. Obviously this is meant to be a bit of a reminder of surds and the like. Not surds, but indices, and that means obviously you're squaring it, so you're timesing it by itself. In fact, that's also a double bracket, so make sure you get the double bracket. This is a cube, so it's that times that times that. I think we had something similar last time, and that's a triple bracket, which we also did last time. So get some answers for me, and that's what I got. I'm trying to remember if we've done something similar before, if it was exactly the same one or if it is different. I think it is different than we did last time, but not by much. Anyway, so formula for a straight line then. As I've already said to you, there is this formula that we use, and it's very useful when you know the gradient m, and you know one point through which it passes, x1, y1 that I've given here. So a little quick example might be, for instance, you know a straight line, and it goes through this point here, and this point here might be, I'm making a point up, it's 5 across and it's 7. And we also get told that the gradient in this line is 3. Well, I just want a straight line. Now, the temptation is to use y equals mx plus c. And if you use y equals mx plus c, you end up doing this. You kind of go, well, I know it's y equals m, 3x rather, plus a constant. But then you've got to find the constant. And the only way to find the constant is to sub these two numbers in. So you say, well, I know x is 5 and y is 7. So if I sub those in, I get 7 equals 3 times by 5 plus c. And that's 7 equals 15 plus c. And you realise that c must be minus 8. And you finish off by writing y equals 3x minus 8. Fair enough, it works. It can get a bit confusing though, particularly if some of these values are fractions. So this is, although it works, this method, you can see it's quite a bit of work. And whenever the m value is a nasty number like 2.5 or 5/7 or 3/4, whenever you get fractions, it gets confusing. So we prefer to use this rule. So we try instead to use this rule. And the advantage of this rule, a lot of the work's already done for you. So you do them in. I know my y is 7 equals 3 lots of now my x. Now notice by the way, the y and the x stays the same. It's the x1 and the y1 which I sub into. What was my x1? It was 5. So multiply out the bracket, 3x minus 15. Of course that's y minus 7. And if I move the 7 over, I get y equals, comes a plus, so that ends up being minus 8. But just notice how little work I've done to get to there compared to all this. Now you perhaps could speed it up a little bit, but this is a simpler method, and I stress, if m was minus 3/4 or something, this is a much better method than the traditional method you got taught at GCSE. So on that basis, we're going to try to use this in a variety of situations. Find the equation of the line, great, but this looks very similar. Now it wants the answer in y equals mx plus c, but that's fair enough. So we just write out the formula, y minus y1 equals m x minus x1. You can see from the last example this formula works. It's a nice little formula. What's my y1 is, oh, it's minus 1. So notice it's minus and minus, so I'm just simply going to write y plus 1. The gradient was 2. And I remember the y and the x, that's the same. It's the x1 and the y1 that go in, and I've got x1 equals 4. Multiply out the bracket, y plus 1 equals 2x minus 8. And so if I just sub it in here, it wants the 1 moved over rather, y equals 2x minus 9, I think. Y equals 2x minus 9, it's underneath it, but you get the idea. The next one is exactly the same idea. I'm just going to do the same thing. Hopefully I'll have a bit more room, but I don't know. Y minus y1 equals mx minus x1. And what's gradient this time is a minus a half. and I've got minus 2,7. So when I type this in, y minus the 7 equals minus a half x. I think it's plus 2 this time because it's minus and minus 2. Because around that room, I'm going to come up here and do it up here. Now look, this is the great trick about fractions. Notice this is effectively it's times by 1 and then divided by 2. That's what half means, times by 1 divided by 2. Now I can just move the 2 over there, and because it's a divide, it becomes a times. This minus 1 I will still times by both of these. So my next line was I'm going to double both of these. I'm going to get 2y minus 14, because it's times by 2, equals, and I've got to times this bracket by minus 1, so I reckon I get minus x minus 2. What does it want? Oh right, this time it wants ax plus by equals c. It wants what is the x's and y's on the left. So I move that way, move that way. I think I end up with x plus 2y equals 12, and I move 14 over, it becomes a plus. X plus 2y equals 12. So it's going like 4 lines there. That included writing out the formula. We sorted it. 4 lines last time. Wrote out the formula. We sorted it. It's a quick, easy process. So let's do this here. Y minus y1 equals. Oh no, this is slightly different. Oh no, it's not. It is the same. It just looks different. It just goes to show. I just wrote out the formula straight away. It says find the equation of the line parallel to this. Now I suppose the very first thing I need to do is I need to know what this is in the form y equals mx plus c. Then I will know its gradient. So that's what I'm trying to get to from this line. And it's quite easy to get to. I move the 2x over, minus 2x. I move the minus 1 over, plus 1. And you can see it's got a gradient then of minus 2. So any line which is parallel to it will also have an m value of minus 2. So learn from that. Going through the point 2, 8, alright, y minus 8 equals minus 2 up to x minus 2. And we haven't got a fraction this time, just multiply it out. Y minus 8 equals minus 2x plus 4. How does it want me to write it? It wants it in the form y equals mx plus c. So y equals minus 2x. Move the 8 over, I reckon plus 12. Minus 2x plus 12. This time find the equation of the line through the point 1, 2, but is perpendicular to the line. Now there's one thing I need to make sure you're aware of, is that you know that lines which are perpendicular, we might not have seen this yet in maths, but you probably saw it last year in GCSE maths. If you have a line here with a gradient of m equal to, say, I'm picking a number at random, 3/4. The line which is perpendicular to it, say going down there, you'll notice perpendicular to it. You have to find the negative reciprocal of this. That might be a phrase you remember, the negative reciprocal, to find its gradient. So if a line's perpendicular to it, sometimes we call it a normal, then you turn it upside down and you find the minus of it. So just bear that in mind. This is just an example. I don't know what mine is yet, but it's worth knowing. So anyway, this is my line. First job I'm going to do is write 2y equals minus x minus 3, because get everything over, and then change it. Now remember, we're trying to find this form y equals mx plus c, because they'll know the gradient. So the 2 effectively means I half those two things. So it becomes minus a half x, and 3 divided by 2 is 3 over 2. Notice I prefer that to 1.5 or minus 1.5. You could write that. It wouldn't have been the end of the world. Notice here the gradient then is of the first line, if you like, is minus a half. And then very often on these you write m1 and then you write m2 for the second one. Well, you turn it upside down and make it negative. Well, it's already negative, so that'll make it positive, minus a minus 2. And you turn it upside down, so rather than 1 over 2, it becomes 2 over 1. And that's the same as actually just 2. So I know my gradient is 2 again. Was it 2 last time? No, it was minus 2 last time. So anyway, my equation for any line is 1 minus y1 equals m x minus x1. So I've got y. Now what's my point it wants? Oh, it's here. Through that point. They always give you that point, so y minus 2. Notice they kind of go in the wrong way around as well. That 2 goes there, but the 1 will go over there. Equals m. What's m? That's 2 lots of x minus 1. So what's my equation? Y minus 2 equals 2x minus 2. It wants it. Well, it wants the x's and the y's on the same side and the numbers on the same side. So I'm going to move them that way this time. I'm going to get 2x minus the y. Actually, I don't think, if I move it over, I think I get 0. Let's see what it says. So that all seems to work. So just what I want to do now is just give you another type of question which you can be asked. And sometimes they don't give you just 1 point and give you the gradient. They say, here are 2 points, find the line through that. And you can see on this slide, I'm basically suggesting to you do the same thing, but first of all you've got to find the gradient yourself. And to find the gradient you use the formula we saw last time, and then you use the formula we've just been introduced to. So it's a relatively easy process. So find the equation, I'm going to line through these points. Minus 1, 2, 1, minus 4. So it says give your answer in the form y equals mx plus c. First of all we've got to find the gradient, so m equals. Now you remember you take the y's away, you take the x's away. So if I do this, use this formula here, I'm not sure what you remember. What happened there? I'm not sure what you remember about finding gradients. Really, this is just finding how far up it goes, how far across it goes. If I was you, I'd pick a value there, that one will do, and I'll do 1 minus the other one. Start with the y's, which seems a bit odd. If I do 2 minus a minus 4, and I divide it by, notice I start with the same one, minus 1 minus a 1. So you take the y's, you take them away, you take the x's and take them away. Now 2 minus minus 4 is 6, minus 1 minus 1, more is minus 2. So I think the gradient is minus 3. Now once I've got the gradient of minus 3, I am able to use either of these 2 points. I only need one of them. So take your pick, y minus y1 equals m x minus x1. And I'm going to pick that one there. Might as well. So my y1 is going to be minus 4. So I'm going to write y minus the minus 4 is plus 4 equals, what did I say? Gradient was minus 3. Lots of x minus, what is x1? Multiply out the brackets, y plus 4 equals minus 3x plus 3. Move the 4 over, y equals minus 3x. I reckon minus 1. Yes, it is. Next question, exactly the same. You've got 2 points, so again we need the gradient. So take a point, might as well be this one, and subtract this one. Minus 2 minus and minus 4. Notice exactly the same point. We're start with minus 2 there. And then we'll start on the same point, minus 1 minus a 3. So what's the top give me? I think minus 2 plus 4 effectively is plus 2. And minus 1 minus 3 is minus 4. So that's the same, I reckon, as minus a half if you simplify that. So again, I can take either one, y minus y1 equals m x minus x1. So take a point. Well, I did this one last time, so I'll do this one again. Doesn't matter which one you choose. Theoretically, you'll get exactly the same answer. It says minus 4, so y minus the minus 4 is y plus 4 equals the m. What was the m? It was minus a half. X minus, what was x1? It was 3. Now notice I've got this fractional thing again. When you get a fraction, you times the other side by the bottom number. I think that gives me 2y plus 8. And you times the top number by these two things. And because it's a minus, it's going to be minus x, I reckon, plus 3. What's it want? It wants everything on the left-hand side. So just bear that in mind. Move the x over. X plus 2y. It was a minus x, going plus. It says 8, but I'm taking away 3. I reckon plus 5 equals 0. Notice it wants everything on the left-hand side. X plus 2y equals 0. Oh, plus 5 equals 1, sorry. So you've got an idea of what we're doing now. We'll practice this in a lesson. Relatively nice topic. And that should then finish off exercise 6B. Best of luck.